Section 1.15, solving equations, goes through all of the ways that you can, all the equation types that you're going to see, as well as dealing with how to find zeros, which is, again, finding and solving an equation for when y equals 0. So let's go through each of the different types of things. So, you could see a line. Well, a line you normally see is something like mx plus b. Well, if you had 0 equals mx plus b, which is that'd be finding our 0, we want to try to solve for x. So we would kind of subtract our b over, and we can get that x to be negative b over m. Fairly straightforward process for a line, so we need to be able to make sure that we can solve for x for a line. Well, we also have, a quadratic. So quadratics look more like ax squared plus bx plus c equals 0. So we all can kind of remember the quadratic formula that says that in this situation x is going to equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You could also factor. That is more of something we worked on before. That's not as straightforward a process as the quadratic formula, so you have to kind of pick and choose your battles there. The big thing is just look at the situation. Is it easily factorable? Most of the time you should be able to do it, but otherwise this is another method that we can use. Cubic functions would be kind of the next one. Now, cubic functions, we can factor some of them, but for the most part, it's very difficult to solve because you're not only look at what you have to do for the quadratic formula. Cubics are adding an extra factor on top of that, so it's not always very easy. One thing that you're going to look to do with cubic functions is you're going to want to try to factor them. So so the first step is try to factor. Oftentimes, you'll see like a cubic function will actually have a common factor throughout it. So, let's say an example being like x cubed minus x equals 0. Well, this is a cubic function. You could try to factor out an x and get left with x squared minus 1, which that's a quadratic, and so then you can kind of factor from there. And that can help you figure out how to do these. Now, not all of them are like that, but always try to look for what's in common. Look for what is in common. Now, this rule, this follows for anything bigger than a quadratic. If you're dealing with anything bigger than that, you're going to need to try to find something that's in common, because otherwise the combinations become too difficult to see when it's that high of a degree. So let's talk about absolute values. So when we have absolute value functions, the big thing to understand is that the inside of an absolute value could be two different things to create the same outcome. So like, let me do an example here. So like the absolute value of x, if that equaled 3, we know that x equals 3 or x equals negative 3. So that can sort of change how things work, if we're given different types of functions. Now, it doesn't always have to end up being two different things because of the way it works, but it definitely always has the option to be the opposite of whatever it equals. So if we look, so the absolute value of x plus 10, if that equals 1, let's say, then we know that x plus 10 equals 1, or x plus 10 equals negative 1. And so we can go from there to find that, okay, well, x is going to be either negative 9 or x is going to be negative 11. So either of those work. And so just following along that process, making sure you're accounting for that as you move forward with absolute value functions. One that is often overlooked, so there are rational functions. So these are functions that are expressed in terms of a fraction. Now there's a couple of things that you want to know about these types of functions, and that is, firstly, it depends on what's on the right side of the equation. So let's look at two examples here. So one of them, I'm going to leave a number on the right side. So like x over x minus 2 equals 3. So in this situation, what we can do is actually multiply both sides by x minus 2. So this is fine because, you know, I'm not getting rid of anything. This becomes, you know, x equals 3 times x minus 2. And we can go forward and solve. You know, we get 2x equals 6. So x is 3. And that certainly makes sense if we plug it back into the top. That changes a little bit when I get, let's say, a different function. So like x over x minus 2 equals 0. So what we want to think about when you see a rational function equaling 0, think about how that works, right? What can I divide by to get to 0? You know, really anything. X minus 2 can be anything, right? But x minus 2 cannot be 0, right? 2 does not make this function 0. It actually makes it undefined. So this is actually a great part. Anytime you see a rational function equaling 0, the only thing that can do that is if the numerator is 0. So we kind of can jump straight forward and say, okay, well, that's the answer. Whatever the numerator is, we'll make it 0. Now just be careful in case there's some value other than 0 on the other side. You've got to deal with that by multiplying and working through. Okay, so we're going to talk about exponential and logarithms to close out. Exponential functions. So let's look at, you know, if we have, say, e to the x equals 5. Well, we learned earlier that in order to find the value for a, or in order to undo an exponential function, we need the natural log. So the way that I would suggest dealing with this is thinking about how to write this as a natural log, or again, completing the natural log of both sides of the function. So there's a couple of different ways to think about this one. If you did the natural log of both sides, the natural log of e to the x is just x, and then you're left with the natural log of 5. And that's an exact answer. So this is something you can always do. Now, again, many of these functions have multiple layers to them, so you have to consider what to do after each step. So really take your time and be thorough with the problem. See if there's anything you can simplify as you move along. And our last one is a logarithm. So logarithms, and again, they come in a couple of different ways. So let's see, we have the natural log of x equals 7. Well, what we do is we take each side to the e. Right? So we kind of think of it like e to the natural log of x equals e to the 7th. And e to the natural log of x is just x. So that is how we can solve those out pretty quickly. Now these work the same for other types of logarithms, and so like if it's not e, so you know, let's say if it's not e to the x or natural log of x, you know, you could see things like, you know, 5 to the x equals 11. Okay? Well, we would do the log base 5 of both sides. And you would just end up with x being the log base 5 of 11. And likewise, if you had, you know, the log base 3 of x equals 2. You know, we could take 3 to each side, so you get 3 to the log base 3 of x equals 3 squared, and this would just become x equals 9, right? We can work with these if it's not e or natural log. They work the same way, except we're just using logs and things of different bases.